5.3, the natural logarithmic function integration. So first of all, remember when we took the derivative of the natural log of u with respect to x, this was equal to u prime over u. Okay? So, if we go the other way, this will be the antiderivative. Okay, so if you have, think of this as being 1 over u du. Okay, so if we take the integral of 1 over u du, that's going to be equal to the natural log of u plus c. But here, we have to take the absolute value of u because that's the definition of a natural log, that whatever you plug in here, that has to be positive. Okay, so this is the rule, which will, if you memorize this rule, you'll have this one by default. Okay. Yeah, let's not worry about that. Alright, so let's look at this one. So first of all, I'm going to write this like this. I'm going to make this 1/2 1 over x dx. Then let, this is overkill, let x equal u. So dx equals or the derivative of u with respect to x equals 1. So du equals dx. And then we just do substitution here. So 1/2 1 over u du, where this would equal, here's the rule here, this would equal 1/2 the natural log of u plus c, where u is equal to x plus c. So that would be the answer there. All right, let's look at another one of these. So first of all, we're going to see if we're able to use 1 over u du equals the natural log of the absolute value of u plus c. We're going to see if that's the case. I'm going to try to let u equal 4x minus 1, where the derivative of u with respect to x would equal 4. So du equals 4 dx, or dx equals du over 4. So I got 1. This is going to be u, and dx is going to be du over 4. So now I can rewrite this as 1/4 the integral 1 over u du. And now I can use this. So I'm going to get 1/4 the natural log of the absolute value of u plus c, where u is 4x minus 1. All right, example 3. Find the area of the region. So we're finding the area underneath this curve. So area equals the integral from 0 to 3 of x over x squared plus 1 dx. Again, I'm going to see if I can use the integral of 1 over u du equals the natural log of the absolute value of u plus c. So first of all, let u equal x squared plus 1. So the derivative of u with respect to x would equal 2x. So du equals 2x dx. I don't have a 2dx, so I'm going to make this du over 2 equals x dx, because I have an x dx. Also, I got to change these limits of integration. So notice when x equals 3, u equals 3 squared plus 1 equals 10. When x equals 0, u equals 0 squared plus 1, which equals 1. So this equals 1 to 10. Dx is du over 2. And x squared plus 1 is u. So this is 1/2 the integral from 1 to 10, 1 over u du. Then if I find the antiderivative, it's going to be 1/2 the natural log of the absolute value of u. And I'm going to evaluate this from 1 to 10. So this would be 1/2 the natural log of the absolute value of 10 minus 1/2 the natural log of the absolute value of 1. So let's see, the natural log of 1, I believe that's 0, because e to the 0 power equals 1. So that's just going to be 0. So this would be 1/2 natural log of 10. And we could think of this as being the natural log of 10 to the 1/2, or the natural log of the square root of 10. All right, I think that's good. We'll do example 4 next.